Right, so we got Unit 7, Lesson 10, rewriting quadratic expressions in factored form, Part 4. Okay, so 10.1, which one does not belong? Quadratic expressions. Go ahead and try to figure that out, and I will go back to it. So go ahead and pause and try to figure out which one does not belong. All right, so hopefully you paused it and try to figure that out. These are quadratic. All of these are quadratic. I mean, this is in factored form, yeah? So that's in factored form. But it's still x times x, which is x squared, so that's quadratic, yeah? So this is in standard form. All right. You still get the x squared there, so that's still quadratic. This is a difference of squares, right? There's no middle term, but it's still x squared. So difference of squares. All right, and I believe that was lesson 8, by the way. All right, just calling back from the past. And standard form, right? Still having to do with x squared, which is a good indicator it's still quadratic. So you can argue for all of them. You know, you could argue C doesn't belong because it doesn't have parentheses. B doesn't belong because it's not in parentheses. D is not, doesn't belong because it's not in parentheses. Or A doesn't belong because it's not in standard form like all the others, right? Or you can argue all types of ways. There's no real wrong answer. Very open to interpretation, which is good. It's good to have that. All right, 10.2, a little more advanced. So each row and each table has a pair of equivalent expressions. Complete the tables. If you get stuck, try drawing a diagram. All right, so 3x times x, right, is 3x squared. And 3x times the 4 would give you 12x. And the 1 has to distribute as well. So you get the 1x or just x. It's really up to you on how you want to look at that. And then make sure you combine like terms in the end. So 3x squared plus 13x plus 4. All right, so go ahead and try the next one here and the next one here. Very similar to what I just did. And I won't go over that maybe unless tutoring on Wednesday. Okay. So that's basically what you're doing there. All right, now we're going the other way. So this is a little bit more interesting. So we have to think about how we want to approach this. We're going backwards, right? So we're going to have the 5x squared, but the x values, whatever they were, right, they had to add up to 21. While at the same time, we have to think about how in relation do they get you that constant. So we still have to keep that plus 4 in our mindset on where we want to go with that one. So go ahead and pause it. I want you to try to figure out how we should approach this one. And this is a very powerful technique, which I call factoring by grouping. So go ahead and try to figure that out. All right, so hopefully you paused it and you tried to figure out how you wanted to get around that whole situation. Let's think. Did you try having a 4? Or we need, if we did, trying to be clever here, if you did 20, right, and 1x, that would add up to 21x, yeah? And you could factor out the 5, right, from the 5x squared and the 20x, getting you the 4 there. And I could also factor out the x as well, right? We have two x's, and we have 1x in 20x and 1x, 2x is actually in 5x squared, but we're going to take one out, right? So you could take a 5x out of both of those, because the first half, right, you have 5x squared, which is really just 5 times x, and 20x, which technically I'm going to break this down a little bit more, right, which is 5 times 4 times x. So all I really did was I took out the 5x from both of them. And for some odd reason, there we go. My computer was freezing for a second. Got scared. All right. And we still have the 1x plus the 4. Do you notice how you have the x plus 4s popping up at the same place? Let me go ahead and highlight that for you. Whenever your binomials are the same when you're factoring by grouping, it's a good indicator that you're doing it correctly. So what did I factor out of the x plus 4? Well, you can factor out a 1, right? I mean, it's 1x, and right, 1x, 1 times x, and 4 times 1. So I could factor out the 1. Never ignore the good old-fashioned 1, okay? All right, so my answer in the end is 5x plus 1. So 5x and 1 are multiplying to the same binomial, x plus 4. You see how I did that? So that would be my factored form for this situation. So this is factoring by grouping. And I want you to go ahead and try the next two on your own. And I can swoop in if you need to for the second one. The third one I really want you to do, if you don't end up getting it, this Wednesday for tutoring for sure. All right. All right. So pause the video, try the rest of the table. All right. So hopefully you paused and you tried your best. And we have this one over here, right? So we have 3x squared and 15x, right? So something has to add up to get that 15x. All right, and we have that constant term, the 12, right? So let's think. We have 3 and 5, right? 3 times 5 would give us something to work with. So the question is let's see, what about, well, what do you think? What should we do? Should we do, if we break it up by 5 and 10, that won't work because we need something to be factorable by 3. Let's try, what if we try 12 and 3? 3x plus 12x is 15x, yeah? And you can take a 3x out of the first grouping here, right? So just to let you know, what I'm looking at is this first part only, okay? They both have a 3 and at least an x, so I took that out. And it ended up giving me that right there. You see that? The 12x and the 12, those have what in common? A 12. You take out a 12. And if you do that, you end up getting x plus 1. Now, remember what I said. If you get your two binomials to be the same, you did it right. So you ended up getting 3x and 12, which both are multiplying to the same thing, x plus 1. So that would be your answer for the second part of your table. All right, so try to factor the last one, and on tutoring, I can go over that for you. All right, but I definitely want you to try the last one of that. and try to keep the idea of what can you add up to get you your middle term, but at the same time you want to be able to factor and get those two binomials to be the same to confirm that you did it correctly. All right, so what is this one? Timing a blob of water. Sounds fun. All right, so an engineer, so this is context. Good, we haven't seen context in a while. All right, so an engineer is designing a fountain that shoots up drops of water. The nozzle of the water is launched 3 meters above the ground. I guess that's why this plus 3. 3 meters is pretty high. What is that, 9 feet? Above the ground, it shoots out a drop of water at a vertical velocity of 9 meters per second. That's what that 9t means. And -5 is the gravity, right? Because what comes up must come down. So should have something going on like this. How many seconds until it hits the ground? Well, aren't you just setting this equal to 0? Right? Because this is the height. So height is 0, right? So how would you write an equation to solve for it? Basically, just -5t squared plus the 9t plus the initial height, 3, equaling the height of the ground, which we're assuming is 0, right? Now, number 2, try to solve the equation by writing an expression in fact form using the zero product property. So this is going to be a little bit more like the table. The interesting thing about this, though, is you got the -5 there and 9, right? So that's an interesting one. So let me try, all right? And in fact, you know what? You try. You try number 2. See if you can factor by grouping, and you're going to struggle a bit. And I believe you can't write this one in factor form, but you know what? I really want you to try, and I'm going to try as well once you really toss your hat in the ring. So go ahead, see if you can work on it, chew on it, and we'll continue the video. So go ahead and pause and try. All right, so hopefully you paused, you tried, and you just have a big mess all over your paper, and you're just like, what? Okay, that's a good place to be, by the way, for a human. So let's think. -5t squared. What makes up 9t? What about 5t plus 4t? That doesn't work. That doesn't work because if you do that, yeah, it adds up to 9, but you can't factor with the 3 over there. See how that causes an issue? And if you forced it, what, 3t and 6t adds up to 9, but that won't factor with the -5. You see that? Like this is now an issue as opposed to this being the issue. So I think that's why it can't be factored in such a manner. Now try to solve by graphing the function. So graphing technology, good cough cough, use Desmos. Okay, so use Desmos, alright.com, graphing calculator, and try to graph that. And you should see your answers, or at least one of your answers. I think one answer is going to be negative, right? So ignore the negative, right? But you're going to get some positive value there on your x-axis, and that would be your solution, which is in seconds. All right, so you should get your answer by using Desmos. All right, that's the end of the lesson. Have a beautiful day.